Welcome to this video on Archimedes' principle, where we will explore the concepts of floating and sinking. Archimedes, who lived from 287 to 212 BC, was a preeminent Greek mathematician and inventor. He made significant contributions to geometry, arithmetic, and mechanics. Archimedes' principle states that when an object is totally or partially immersed in a fluid, it experiences an upthrust equal to the weight of the fluid displaced. This principle helps explain floating and sinking. The key concept is upthrust, or buoyant force, which is the upward force that reduces the object's actual weight underwater. For example, a 100 cc metal block displaces about 1 n of water, making it feel 1 n lighter. In this example, an aluminum block with a volume of 100 cc weighs 2.7 n in the air. When submerged, it displaces 1.0 n of water, resulting in a spring balance reading of 1.7 n. In this second example, a piece of wood floats. Because it is floating, the spring balance reading for the wood, if attached, would be 0. From Archimedes' principle, the buoyant force is equal to the weight of the fluid displaced, which can be expressed as mass times gravity. By substituting density times volume for mass, the formula becomes buoyant force equals density times volume times gravity. For flotation, buoyant force and weight determine the object's movement. If the buoyant force equals the weight, the object floats stationary. If it is greater, the object moves up. If less, it moves down. The law of flotation further states that a floating object displaces its own weight of fluid in which it floats. For instance, a ship and its cargo weighing 500,000 tons must displace an equal mass of 500,000 tons of water to float. Consider this question. Why is the depth of the ship immersed in water different in these four scenarios? The answer lies in density. Fresh water is less dense than seawater, and warm water is less dense than cold water. Therefore, more warm fresh water must be displaced to maintain an upthrust equal to the boat's weight, allowing it to float. Another question. If plasticine is formed into a ball, it sinks. When formed into a hull shape, it floats. Why? The plasticine ball sinks because the displaced water weighs less than the ball. The hull floats because it is shaped to displace a volume of water whose weight is equal to the hull's weight. Archimedes' principle has many applications, including hot air balloons. A balloon rises when upthrust is greater than its total weight, descends when it's less, and remains stationary when forces are equal. The Plimsoll line marked on a ship acts as a guide to ensure safe loading limits, as the density of seawater varies with location and season. TF, F, T, S, W, and WNA correspond to different water conditions. Submarines use ballast tanks to control depth. When tanks are empty, upthrust is greater than weight, and the submarine rises. When tanks are full, upthrust is less than weight, causing it to sink. A hydrometer is an instrument used to measure the density of a liquid. It includes a thin stem, an air-filled glass bulb, and lead shot to keep it upright. The hydrometer sinks lower in a liquid of lesser density. Let's work through an example. To find the buoyant force acting on a rock submerged in water, subtract its apparent weight, 0.45 n, from its actual weight in air, 0.85 n. The buoyant force is 0.4 n. In this second example, a concrete slab weighs 180 n, and its apparent weight underwater is 105 n. The buoyant force is calculated as the actual weight minus the apparent weight, which is 72 n. According to Archimedes' principle, the buoyant force equals the weight of the displaced seawater, F equals PVG. Rearranging this to find density, we get P equals F/VG. Plugging in the values yields a density of 1,530.61 kilograms m³. This concludes our video on the principles of floating and sinking. Physics is simply fun.